Hi guys, let's take a look at section 5.3, which is on associations between categorical variables. And really what we're still talking about probabilities, but we're getting into a few more different types of probabilities and how we can look at two categorical variables that may be related. So a couple of objectives here. The first is to be able to find conditional probabilities. We'll talk about what that means, how to calculate conditional probabilities, and to determine if two events are independent or associated. And that, of course, relates to that conditional probability. So make sure your cell phone is put away and you're ready to go. So first of all, what is a conditional probability? Well, a conditional probability is a measure of the probability of an event given that another event has occurred. So given that we already know something else has occurred or that someone is in a certain category, what is the probability of this event happening? So given that something else has already occurred, that's called a conditional probability. We might write it as the probability of event A given that event B has happened, and notationally, here I'm going to come down here and write it, we'd write the probability of A, and then we put a line there, given that B has occurred, and that's what that would mean for us. So that line means given that. What is the probability of A given that we know event B has already happened or already occurred? So let's look at this table. This is called a two-way table because we're looking at two different variables and numbers for each of those categories. We're looking in this example at highest educational level versus income level for a sample of full workers. So we've got a sample of people and we've asked them, it's a survey I suppose, where we ask them what their high education level was versus their income level. So part A says, find the probability that a person is of high income given that the person is college educated. So first of all, how can we write this notationally? So I'm going to say the probability that somebody is high income. I'm going to use H for high income, and then given that, so that's that line, given that they're college educated, so I'm going to put a C for college educated. So in a question like this, remember with probabilities, we want to write it as a fraction. I like to start with the denominator on these conditional probability questions. Whatever follows given that is the only group that I am interested in. I'm only interested in the college educated group in this particular question, given that we know someone is college educated. So in the two-way table, I'm going to focus strictly on the college educated column, or this group right here. There are 181 people who are in that category. So of those 181 people, how many of them are high income? So just looking at this column, how many are also in the high income category? And it looks to me like it's 77. So the probability that somebody is high income, given that they are college educated, is 77 out of 181. But like I said, I always start with the denominator on a question like this, and whatever follows given that is going to tell you your denominator. Let's do the next one. Find the probability that a person is low income given that they are high school educated. So I'm going to write it as the probability, I'll use L for low income, given that they are high school educated. So, gosh, I should have picked, I'm going to use HS for high school. How about that? We'll go with that instead of H. So whatever follows given that, that's my denominator. That tells me the group I'm focused on. So I'm only focused on the people who are high school educated. It said there's less than high school and high school. So I'm gonna assume they mean this category right here. So of the high school only group, there's 110 people. So that becomes my denominator. Within that group, how many said they were low income? That would be this group right here, and that's 58. So given that I know somebody is high school educated, 58 are low income. Notice in neither of these examples did I use the 406. That's the entire sample. I'm not interested in relative to the entire sample. I'm interested in relative to whatever follows given that. And so that's what determined my denominator. How about C? Find the probability of a person who has less than a high school education given that they are high income. So we're going to say the probability that somebody has less than a high school education. I need a different variable. I'm going to call it, I'm going to say less. I'm just going to write that word out. Given that, so whatever follows given that they are high income. So high income, I think we said H for that earlier. So this time I'm looking at the group of people who are high income. Remember to start with your denominator. So the denominator, let's take a look. High income, I'm looking at this group right here, only the high income people. So of the high income people, well, I have 109 in that group. How many in that group said they have less than a high school education? And that would be this group right here. So that's 12 out of 109. When we have a conditional probability question, usually we're going to work with the table, but occasionally we may not have the table and they may give us specific probabilities. And in that case, we will use a formula, which I'll show you in just a moment. One note I want to make is a difference between given that, which is a conditional probability, and the word and in a question, which means both. So remember that given that means on the condition, given that somebody is in a particular group, whereas and specifically means somebody who is classified as both. But when you're talking about and, they're relative to the entire sample. So for example, in this question above, the probability that somebody is high income and college educated, that's the intersection. So that would be, if I'm looking at a Venn diagram, high income, college educated, that would be this group right here. And so my probability for that would be relative to the entire sample. If I went back to the sample, relative to the entire sample, let's see, so the entire sample, there are 406 people. How many are both categories? What were we looking for? I forgot what the question said. Let me go back. The question said high income and college educated. So high income and college educated, that's this group right here. So that would be 77 out of 406. On the other hand, this is the probability that somebody is high income given that they are college educated. So in my Venn diagram, the probability that somebody is high income given that they are college educated. So of the college educated group, it's the same. Let's see, maybe the Venn diagram is not the best way to say it. Well, let me do it this way. Let's get rid of this part. So given that they are college educated, what is the likelihood that they are high income? So what changes is my denominator. Now I'm only interested in the college educated group. So if I go back, the college educated group was this column. There's 181 in that group. So it'd be out of the 181 who are college educated, how many were high income? See it? It's 77. So the numerators are the same, but the denominators are different. It's relative to who you're talking about. Are you talking about the whole sample, or are you talking about just the college educated group? And that's really the difference. So given that means you are only focused on one group, whereas when you see and both, it's relative to the entire sample. And that's really the big difference. And we'll practice this in class. When given data in a table, make sure you calculate the conditional probabilities the way I did previously by isolating the group that you're sampling from. But if the table is not given and you're asked about a conditional probability, we can still use a formula to help us calculate the conditional probability. We could figure that out by doing the probability of A and B divided by just the probability of B. If you'll notice, actually, that is what we did back here in a way. Let me come back to that in just a minute, and I'll show you how that works. So the probability of A given B can be found by using this formula if you need to. And you know what? I'll tell you what. In class, I'll show you an example where you can see how this formula could have also been used to calculate this, even though we had a table. I'll show you how those two things work. Last thing I want to touch on is independent events. So that's related directly to conditional probability, and we'll talk a little bit more about that in class as well. But the probability, or two events are independent. So events A and B are independent. Basically, if they don't have any impact on each other, if they don't affect each other. So if the occurrence of event A does not affect the probability for the occurrence of event B, so they have no impact on each other, they're independent. This is not the same as mutually exclusive. With mutually exclusive, that meant that they could not occur at the same time. Independent events can occur at the same time, but they don't impact each other. For example, I could flip a coin and I could roll a die. Now, I could do those at the same time, but what happens with the coin has no effect on what happens with the die. That's what we mean by independent. Symbolically, if events A and B are independent if the probability of A given B is equal to just the probability of event A. And vice versa, if the probability of B given A is equal to the probability of event B occurring. And we'll talk more about in class why this is true, so you can see algebraically why this is happening. But it goes back to this formula up here. Last thing, the multiplication rule for independent events. So if you're asked about an AND probability and you know that A and B are independent, then the probability of A and B is going to simply be equal to the probability of A times the probability of B. So as long as the two events are independent and you need an AND probability of both events occurring, that would be the product of the two events on their own. Put a little star by that because that's an important example. And I know these formulas can get a little overwhelming, so we'll do plenty of examples and practice in class tomorrow. So make sure you bring your notes, and I'll see you then.